Hello everyone, welcome to our channel Code with Sunny, and today I am going to discuss the problem deepest leaves sum index number is 1302 and the problem is of medium type of LeetCode. Okay, so let's discuss the problem now and find out the best solution of this problem. We have been given the root of a binary tree and we have to return the sum of values of its deepest leaves. Okay, so we need to find the sum of the leaf nodes and those leaf nodes which are going to be deepest with respect to the root node. Okay, so how we are going to do that? It is just simple. Let's find out the first deepest leaf node and then we are going to sum up all those leaf nodes values. Okay, so if you are not going to still understand, okay, so no need to worry about. I'm going to explain this with the help of example. So let's move further. Okay, so here you can see I have taken the example of a binary tree and we need to find out the sum of the deepest leaf nodes. Okay, so let's find out what are the leaf nodes over here. So you can see this is the leaf node because it doesn't have any left child and it doesn't have any right child. And let's talk about this node. It doesn't have a left child as well as right child, and this node also though. So there are three leaf nodes in this binary tree. Okay, so now we need to find which node is going to be the deepest node. Okay, deepest means of maximum depth. Okay, so how we are going to calculate the depth? Note that in a binary tree or in any other graph with a fixed root node, we are going to calculate the depth of each node with respect to that root node. Okay, so how we are going to calculate that? Just assign the level equal to 1 to the root node and to its child as level equal to 2, and again further increase the depth by 1, and it should be like it is at the depth equal to 3, and it will be at depth equal to 3, and this one also, and finally you can see these are at depth equal to 4. Okay, so if we are going to find out the level of the, you can say, level of the leaf nodes, you can see it is at level equal to 3 with respect to root node, and this will be at level equal to 4, and this will be at level equal to 4, and we need to find the sum of deepest leaf nodes. Okay, so we need to figure it out what is the deepest leaf node over here with respect to this root node. You can see this is at maximum depth, that is at 4 and 4, and this is at 3. So we need to find out the first maximum depth, and which is maximum depth is 4, and the depth of corresponding leaf node. Okay, and it is at 4, and find out the sum of all those leaf nodes whose depth is going to coincide with this value. You can see whose depth is going to coincide with this 4. You can see this is one of the leaf node whose depth is going to coincide with 4, and this is another leaf node whose depth is going to coincide with 4. I need to find out the sum of the values of these nodes. Okay, let's say it has the value s1, and let's say it has the value s2, and we need to report the answer as s1 plus s2. This will be our answer. Note that to find out the, you can say, the depth of a binary tree, that is depth of each node of a binary tree, or you can also say the maximum depth of this binary tree. So we need to have an efficient algorithm, or you can say efficient approach to find out the maximum depth, and you can find out the maximum depth with the help of two approach, either DFS, depth first search, that is you're going to traverse to the deepest of the node and find out the maximum depth. Okay, or you're going to find out the maximum depth with the help of BFS, breadth first search. Okay, so let's find it out what is going to be the an efficient solution of this problem with the help of depth first search and breadth first search. So let's move further to find to the coding part. Okay, so okay, so let's talk about depth first search, how we are going to implement my solution with the help of depth first search. Okay, so I'm going to write here as DFS, and let's take a global variable int sum as 0, which is going to be our answer basically. And when I'm going to just traverse during recursion, if I'm going to take this as a global variable, this will be very much helpful instead of passing parameters to every time at every function call. Okay, and let's take a maximum level also variable that is going to store what is the maximum level of you can say max. Okay, let's say maximum depth of this node as 0. Okay, so which is going to find out the maximum depth also of the binary tree, and let's write out the function to find out the maximum depth. Okay, so here it will be like a maximum depth, and let me write it as maximum depth. I should make it as int, and let's write it as level, and let's have a parameter pre-node star root. Okay, and if root is going to be like okay, so if root is going to be like null, just return 1. Okay, I'm going to return 0 because there is no node over there. Otherwise I'm going to return 1 plus maximum of this height of this left node. You can see I'm talking about suppose we are at this node, and you can see left one has a height of 1 and right one has a height of 2. So I need to return the maximum of this plus 1 because of this node. Okay, so I'm going to just do this stuff, return 1 plus max of I'm going to just call it as like a recursion. Okay, 1 plus max of level of passing as roots left, and it would be like again calling this level 1 and passing it as roots right. Okay, so I think this is fine, and I need to just process this deepest leave sum also. Okay, so let's find it out how I'm going to do that. So it should be like first find out the maximum depth. Okay, so I'm going to write it as max. I think this variable is of no need. Okay, yes, this may be needed. I think I should make it as here also. Okay, so I should write as max depth as get the max depth of this root node. I should pass as level, call this level function and pass this root node as a parameter. So this will store as maximum depth. Then I call a DFS function with this root node and passing the level as 1 for this root node, and find out the entire sum of the deepest leaves nodes. Okay, so I am going to write it as get sum of deepest leaves nodes. Okay, and this is for get maximum depth. Okay, so if I have got the deepest leaf sum, just return sum as it is. Okay, but I need to implement this DFS function, so it would be like a tree node root as a parameter, and if root is going to be like null, just return, because I'm not going to proceed further. And if it should be like if okay, so I'm going to just make a comment over here. If we encounter a leaf node with with maximum with max depth. Okay, so just check it out. If it is a leaf node, that is root's left child is going to be null, and root's right child is going to also be null. Okay, and it is at maximum depth. So because I am passing there 1 as a parameter, which is actually the depth, so I am going to just do one thing, int depth. Okay, and I'm going to write depth equals max depth. If this is going to be true, just to sum up all the nodes values of these nodes. Okay, and otherwise just call the DFS function to the root's left child and passing the depth as 1, increase, that is incremented by 1, and I'm going to just call it as also roots right as right child with depth 1 more. Okay, so I think this is also fine. Okay, so I think I have done with the entire one. So let us cross check. Int sum 0, max depth is also 0, level I need to find out the level. Note that I'm going to just do this because of we need to process the maximum depth. That's why I'm going to take the maximum of left child value and the right child value. Okay, so I think I've done over the entire thing. Okay, so here I missed one thing. Roots right should also equal to null, and roots left is null. Okay, and max depth equals level of root, then call the DFS of root, and we need to increment the depth plus 1 every time. Okay, I think this is fine. Just run this code, rather I should have submitted. Okay, so it is accepted for now in this compiler. Let's submit this code. Yes, it is good, you can see. So depth first search is also giving the correct answer. Okay, so let's find it out how we are going to implement this with the help of breadth first search. Okay, so let's talk about breadth first search approach to find the best solution of this problem. So let me comment it down and write it as BFS. Okay, so just do the implementation as fast as possible. Okay, so I'm going to just similar to the case of previous, define sum as 0, int max level as, okay, so max level should be like defined with 0. I need to take the maximum finally. So I'm going to just make a queue pair of tree node. Okay, it should be like pair of these two values like tree node, and again pair would be like level. So I'm going to just explain it a little bit. It should be like a pair of this first node and its level. It should be like, you can see when I'm this root node, I am just storing this node's address plus the level associated with that. Okay, so it should be stored in like q pair tree node comma int q. Okay, so I need to push up the root node and with the level as 1. Okay, so just I'm going to write find out the maximum depth of the binary tree. Okay, so I'm going to just find out with the help of breadth first search. Okay, so just iterate over like that while q is non-empty, and we need to just find it out, pop out the first element from the queue. Okay, so it should be like just take us the node, tree node star, and it should be like node q dot front, and we need to take up the first element of the pair, and again should be like level, like int current level should be like q dot front, and it should be like second element of the pair. Okay, so just pop it out the element from the queue because it is of no use now. Now I need to take the maximum, take maximum. It should be like max level should be like equals maximum of max level found till now, and take the maximum of this current level. Okay, so if this is done, I need to process for the left child and right child also. So if node's left child is going to be not equal to null, then I can just process this node's left child to, that is I'm going to push this node's left child into the my queue back again. So just push that node's left into the queue with the depth with the level greater than this current level by 1. Okay, and this same thing I am going to do for the node's right child also. So just copy this thing and change left to right only. Okay, so I'm going to just do this as fast as possible. So it is done. Now I have got the maximum level in the max level variable. Okay, now I need to process, like find out the deepest sum of leaves nodes. Okay, so I'm going to just do the same thing because q is empty. I need to push up the roots node and its value as 1, and again process the same thing while q is non-empty. Okay, rather than doing this, just copy this stuff and just bring it out here, and just paste it over here. Okay, I need to change only the single thing, that is like this entire thing would be same. So if okay, so further processing of left and child node, right child node would be done. So for now, if I'm going to check if nodes left is going to be null and nodes right is also going to be null, it means that I have encountered the leaf node, and check if this leaf node is going to be at maximum depth or not. Okay, so it should be like current level, it must be exactly coinciding with the maximum level. Then only I am going to sum up this node's value. Okay, so I think I am done with this entire thing. So I need to finally return the maximum, that is deepest leaf sum. Okay, so let's run this code and check it out if I am correct or not. I think this solution would pass. Yes, it is good. So let's submit this code and check it out if this is an efficient solution or not. Yes, it is good. So if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel, and also join our Telegram channel mentioned in the description section of the video. And thank you for watching this video.